goes. Well, everybody has a wall outlet, and everybody here at Ultra Fidelis obviously has a passion, as do I, for audio reproduction. And mostly that just serves our passion for music and the experience that we want to reproduce as best we possibly can. Now, this is a tricky subject. It's a subject that could be pretty boring, and it's one that was basically overlooked for most of the history of alternating current, or most of the history of audio, and for good reason. For one thing, we just simply didn't have the kind of software that we have today. We didn't have the kind of systems that we have today, going back to the very, very beginning of like audio reproduction for the most part. Certainly in terms of bandwidth, certainly in terms of frequency response, or in terms of dynamic range. There were some notable exceptions here and there, but on average, not really. That's not what a lot of our software was made to serve, certainly going back to the 20s, 30s, and 40s, and even really into the 50s and 60s, with some notable exceptions. Some of those master tapes were absolutely tremendous, but the problem being oftentimes that a lot of the original pressings from those periods, if they thought even for a minute that they were going to be sold to people that were going to be playing on a very, very substandard ceramic cartridge turntable, or that it was going to be optimized for AM radio through somebody's like old car with the hood down, it became a situation of like, how much can we compress this media? How much can we manipulate it to sound good at that equation? Which you understand, because they wanted to serve the artist as best they could under those circumstances. But that's not the circumstances we have today. So it's about like how much closer we can get today. Plus, there's another problem too, which is that the kind of noise we had on the AC line was bad. In fact, for the level of equipment we're talking about in a place like this, really unacceptable, even in the 1940s and 50s. But the level of noise that was on the AC line, even in the 1970s, was less than 1/10,000th of what we have today in 2015. Now, the reason for that is that there's a little bit of history here. One of the reasons for that is the information age, computers. When I grew up, I'm 52 years old. So I graduated from high school in 1981, and my guidance counselor informed me in 1979, Garth, you're on a career path and a college path. You're a bright young man. For God's sakes, what the hell are you doing? I'm looking at your class schedule, and I don't see you in the computer lab at all. You're going to be lost in college if you don't get in that computer lab right now and learn Fortran. And all those old reel-to-reels and everything like that they had in that lab were gone inside a year and a half. But at the time, that's where you went to learn code. So things are moving really quickly, but I was right at that transitional period, where by the time I was graduating high school, all of a sudden the personal computer was born. And all of a sudden, by the time I was starting college, this wasn't just something that was, kind of like a curiosity for people. Everyone had one. Every business has one at every desk. And now everybody's got servers and a server room with an IT professional at just about every small to medium-sized, certainly large business. And what does that mean? Well, what that means is a level of noise back on the AC line that's there 24/7 like we've never seen before. With those kind of digital switching technologies and switching power supplies that came with them that were just basically an afterthought in someone's laboratory even by the early and mid-70s. By the 80s, it was a game changer. Everything changed. And in terms of how light and efficient the computer could be, they were wonderful. But what they did to our AC line, they destroyed it. Here's another thing that changed as well, which is just the fact that as this information age changed, our expectations changed. All of a sudden we went from, wow, isn't it amazing what I could do with this, keyboard and this personal computer on the CRT screen, and all of a sudden then it goes to the flat screen and so forth. And then all of a sudden we have our first generation of smartphones. And cell phones, even the flip phone before the smartphone, and everyone loved them. Well, the only thing about that is that in order to make that equation work worldwide, you've got radio waves that are no longer just AM or FM and shortwave. Oh no. Now you've got cell towers, and the repeaters are everywhere, and this is up in the gigahertz range. Frequencies that are so small. If I took some of the primary frequency ranges that are required for a smartphone or a cell phone, okay, let's talk about how small those are. Well, and I'll get into why that's important. If we talk about a low frequency node, you know, like coming from a concert bass drum, or coming from a timpani, or coming from a pipe organ, or, you know, like the lowest open note of a 5-string electric bass. Well, we're talking about a note that's over 20 feet long. It fills this entire room. If you're talking about, theoretically, the highest frequency that a loudspeaker like a Vandersteen 5 can hit, let's say around 20,000 hertz, actually you can go higher, but that's also as high as they claim we can hear. It's not entirely true, but let's say that for argument's sake it is. That's about 3/4 of an inch. That very high frequency is about that big. Okay. We talk about the frequency that the cell tower is putting out in the gigahertz range and the upper megahertz range. If I took that frequency, it's so small, I can't put my fingers together that close. I could take 200 of those sine waves and stack them end to end, and they fit on the edge of my business card and have plenty of room left over. So the naive assertion that we used to be able to make when I was learning as a teenager and cutting my teeth in electronics, that having a nice chassis like this beautifully made, you know, like audio research amplifier or preamplifier was going to take care of the radio frequencies that come through, or that a cable such as an AudioQuest that has shield with, you know, like that's an advanced shield system with noise dissipation system and carbon loading and everything, multiple shield levels and everything like that. Now all that's important, all that's great. It does do the job, it does work, but is it 100%? By definition it can't be. Nothing can, because these frequencies are so small. Is a chassis like this or a cable like that hermetically sealed? No, it really can't be. Every vent that you've got in a situation like that is thousands and thousands of times larger than the frequencies that are going to come through. It doesn't mean that it's not worth doing this, because you've got a lot of frequencies that are much larger, that are much lower, and it's doing a fabulous job to shield you and protect you against and make sure that it performs properly. But we're fighting a nearly impossible battle now. So the stakes are higher than ever before. Now, I'm an engineer, and I can, you know, like, and I've been in the power game for over 20 years, as Jonathan was kind of like talking about. I was the lead design engineer for Firm and Sound for 16 years prior to, you know, like Bill finally convincing me Bill Lowe at AudioQuest to come and join the company. I'm glad I did. But it doesn't matter whether it's me or anybody else that deals with AC power, or for that matter, that, you know, designs loudspeakers, designs cables, designs preamplifiers, designs power amplifiers. We can get up and talk all day long. We can go through our unique technologies, our proprietary ideas. We can, you know, like spout all kinds of things. How do you know any of them are true? I don't even know if what I'm saying is true. I may change my mind tomorrow. The only thing that I can really trust are two things. One, what I hear and see. And the other thing is that proving these concepts to myself, to where I have enough empirical evidence. That's good science. What I consider bad science is the kind of like pot shots that you see from a lot of electrical engineers, where it's easier just to say that absolutely nothing matters and everybody's making things up and everything's, you know, like a bunch of voodoo and nonsense and snake oil, and yet they're not willing to do any tests, any listening, any verification, anything. That's not good science. That's laziness. Now, I was one of those people that would look at what companies like AudioQuest were doing for years and say, well, I like this and this. I'm not sure this makes any sense to me, and I have my doubts. But I never, the way I was trained, you don't take those doubts and just automatically veer off into, therefore, because I have a doubt, it can't be true. No. It's my job as a scientist to prove it either works or does not work, and here's why. And understanding why is infinitely more important than arriving at some place. Now, so, is there noise? I could be lying. Now, I can't bring $250,000 worth of lab equipment with me, but I can bring this thing from Audio Prism that's been around for 25 years. You know, it's basically, as you know, serious testing equipment is concerned, it's kind of a toy, but it does work. It measures what symmetrical noise on the AC line, and gives you like a general sense of what's there by just amplifying the stink out of it. Let's plug into a native outlet here outside of Milwaukee and take a look. Pretty bad. All right, let's go over to the new AudioQuest Niagara 7000 and plug into one of its outlets. You can hear me plugging in, plugging out. Nothing. I win. We're done. And if I was selling a strip at about $200, you know, I probably could just stop. The only problem is that in reality, here's the problem with this. Actually, there's two problems with this test. One of them is that I can show you from a number of manufacturers AC power strips with filtering for about $200 to $250 and above that can pass the test as well as it just did with the Niagara 7000. So at $8,000, that thing is vastly overpriced, if that's the only thing that I'm after. And then the second thing about this is that, to be fair, I don't think I've ever heard even the worst performing audio systems, you know, even with things that seemed like they were on the edge of being broke, I don't recall an audio system ever sounding in the background or the foreground like this. It's just not really going to happen. That's kind of like a bit of an exaggeration. Because that's not really what's going to happen to your audio system, and it's not that everybody's going to experience hum, and it's not that everybody's going to experience too much hiss. You know, like those are annoyances, and we want to get rid of those things. But good equipment set up properly, we can get around those problems. Those are just simple annoyances. They can be sometimes involved with AC power, sometimes not. Sometimes to do with the ground and so forth. But what we're talking about really, what I'm mostly concerned about is two things. The moniker for the Niagara 7000 series is Low-Z Power Noise-Dissipation System, which is a bunch of gobbledygook and a lot of language to basically say, you know, like a power conditioner, but I didn't want to call it a power conditioner because I've seen that term abused too much for 20 years. And I wanted everybody to know that, look, this is a game changer, year zero, I'm not doing what anybody else is doing. But if you want to call it a power conditioner, I do not care. Because all that matters is if it works for us. Now, there's an insidious level of noise that does exist. This is the noise dissipation, you know, portion of, you know, what I've dealt with and what I deal with in every design that I do. And why does it matter? Let's pretend that this back wall is, you know, a chart. At the top are going to be, as I go across, the loudest audio content that I can likely reproduce out of my preamplifier or amplifier. I'll just call that zero level or zero VU. It's 0.775 volts. All right. And then as I go down this horizontal wall, by the time I'm down here, maybe I'm 60 decibels below zero. And by the time I'm down here, I'm about 90 decibels below. And by the time I'm down here, I'm about 120 decibels below. What the hell is Garth talking about? Why do I care? Well, we care because if we're talking about the kind of signal content that we're going to get from a dance remix, from anything that's Beyonce or Britney Spears, whatever it might be, or something like that, and it's made for a discotheque, and it's an MP3 file, and it's been slam limited. It's got about 3 dB of dynamic range, and all the content is going to be way up there by the ceiling. And the difference between this system and a Bose wave machine is going to be audible, but it's getting to be kind of like marginal. You're kind of scratching your head wondering, is it really worth this investment? Because the fact of the matter is that there's not much left in that content. It's, you know, it's high distortion and it's very low content. But if we talk about the kind of, records, whether it's digital audio, whether it's a Redbook CD, whether it's vinyl, I don't care. All those can work beautifully. Today, a lot of our musical content is very wide dynamic range, very high resolution. It can, have anywhere from 85 dB of dynamic range up to 120, sometimes even 130. And why I care about what's down here at the bottom half or the bottom third, is for this reason. Every harmonic that you hear out of your, acoustic or electrical instruments, all of the spatial cues that tell you that, it's to the right, it's to the left, it's that far back in the stage, everything that tells you that the reverberant feels like this, the hall is like this, the room was like this, everything that makes the thing go from, yeah, it's a high five to, oh my God, they're in the room with me. All of the magic, all the passion, all of the real resolution, the experience that makes it real, The magic zone is 60 decibels below zero or below. The Bose wave machine is about to fall on its ass. It can't do that to save its life. This system, oh my God, it can do it really, really, really well if it's given the chance to do it. But the problem is, as we just heard, there's an insidious level of noise that doesn't sound as irritating and as noisy as that, but it's always ever present. It comes through the power supply, goes through the comes through the AC cords, comes through the power supply, even of the finest electronics. That, to their credit, companies like Audio Research and Moon do everything that they can to eliminate as much of this noise as possible. And actually, the linear power supplies that they use will get rid of sometimes 70, 80, 85% of it. And 30, 40 years ago, that'd have been enough. But today there's so much, even then, it's just not enough. So if I can get rid of more on the way to their power supply, I can allow them to function properly. And now, because what happens is that noise gets in through the power supply, through ground, and it modulates the signal. It couples to it. It distorts it. It gets rid of information. Basically, it's like a blanket, a woolen blanket, over your loudspeaker, over your system. I'm doing, I want this. So I don't have to really be perfect with the Niagara. I just need to take that noise that has gone from being down here in 1970 and now is up here in 2015, and I need to knock it down to the floor so that I get the blanket away from these Vandersteen 5s or whatever loudspeaker, whatever system you might have. That's the trick. So I want to go from this to this. The problem is how we go about this, how we get there. And there's a lot of different attempts on a lot of different manufacturers. I salute them all for trying their very best and understanding that this is important, but not everybody goes about it the same way. With the Niagara series, we are just simply capable of doing with far, far, far more octaves of noise reduction than anybody else, and at the same time being far more consistent, or electrically what we would call linear, with our noise reduction, which is just a fancy engineer's term for even, consistent. Why would you care about that? Well, you'd care about that because, think about it. If I've got a warm blanket that's being used for the fan and I want to yank it away, what happens if at certain octaves where noise appears and modulates everything, I'm 40 decibels down and I go to this? And then, but unfortunately, an eighth octave away, I'm only 3 decibels down, and I've gone to this. And then an eighth of an octave from there, I'm 100 decibels down, and I've gone to this. That's wonderful, but then a 16th of an octave from there, I'm only down 5 decibels. And as I go up 21 decibels, I'm going from this to this to this to this to this to this. I've created a mess. It's sort of like I've instead of yanking all of the blanket away, I've taken a little bit away from the, the tweeter. Half of it's still over the mid-range driver and part of it's still over the woofer. I want it all gone. But that's hard to do. And you have to compensate for real world, what's called impedance in your circuit designs and so forth. And a lot of the different technologies that are out there just simply can't do this. This is one of the things that's unique about what we do. But the other thing that's unique is dealing with ground and dealing with it properly. Now, for those that don't know, that's just that third prong that's in your AC1. That's a little, like mouth and that little face that you stare at your wall. It's this tab right here. And it was originally not created to have anything to do with audio or video performance or anything to do with RF, radio frequency shielding. It just had to do with redundancy safety. But the way it's been incorporated for electronics like this, since it was introduced around the end of the 1960s into the 1970s, that's exactly what it's been about. And the common misnomer or misconception that even a lot of people in AC power devices have is that some of them might have a battery, and some of them might regenerate a perfect sine wave, and some of them might, use just big transformers that are very, very well made, and some of them use different types of filters, and some of them use, special types of, proprietary ferrous materials and damping compounds that they've used. Everyone's got a different idea, but what almost all of them do where ground is concerned is they take the ground input and put it to the outputs, and it's just basically a direct path. Essentially, they're doing nothing. And to be fair, when you go to electronics school, you're taught that ground is where noise goes to die. That's like shorting something. That's like going from to, that you just shorted out the signal. Oh, great. It's like hitting mute on your audio research. Fantastic. Problem is, it doesn't really work that way because, again, these frequencies are so small that actually ground ends up, as it turns out, being a fairly effective antenna. So we've developed something called ground noise dissipation to effectively deal with that. It's significant, it's important, and so much so, I received a patent for it, 6 months ago. One of 2 patents we've got from the Niagara series since I came to AudioQuest 3 years ago. But again, I could be fibbing. How do we know I'm right? Let's prove it to ourselves. Never believe me or anybody else. Okay, let me turn on this Cambridge. And if it sounds anything like it did this morning, I think we're just going to get a bunch of white noise. But even though it's turned on to the FM station, it's a local FM station, it's a little weak. Now, we're only hearing white noise, to be fair, because there's nothing wrong with the Cambridge, it's just that there's no FM antenna hooked up to it. It needs a coaxial cable. Well, it'd be nice to have a real antenna or dipole hooked up to it, but instead of doing that, let's do this. Let's take a cheap AC extension cord, and the only thing that's unusual about this extension cord is that I've basically spliced into just the ground wire of this to the coaxial connector that goes on the back of this through this adapter. That's all we've done. So basically, it's just the ground wire in this AC power cord. And also, human bodies tend to be somewhat conductive, so we have a little bit of audience participation. Here's what we're going to do. If I can get some of you fine folk in the front row to pull the cable so that the conductivity in your hands and your bodies will get involved in this. And let's see, now it's not a real antenna, but let's see if we have any chance of getting any kind of FM signal through the, like the ground wire of an AC cable. Let's see if there's any noise, like coming through ground at all. It works pretty well, actually. That's a pretty damn good antenna, which tells me we need to get rid of a bunch of this before it gets directly into all of my preamp, amplifier, CD, and vinyl circuits. Now, on the other hand, let's watch for, what's up my sleeve here, because a real engineer would try to correct me and say, Garth, what are you doing? This is just a floating ground. We need to ground it properly. Now, there's a ground rod here at Ultra Fidelis. We need to hook ourselves up to it so they could properly ground to earth. They'd be correct. So, to really do this properly, I better plug this antenna into the wall so we can put it into the Ultra Fidelis ground and watch the FM signal go away. If anything, it just got a little better. Real ground that can actually dissipate noise is at one teeny spot at like about a square millimeter deep inside the ground. Everything above that is effectively an antenna. So we want to do something about this, and the Niagara series is the only unit in history for AC power that's really effectively dealing with that problem. One of the many. Okay. Now, as I talked about, there were 2 monikers for the Niagara series. One of them is noise dissipation. We've just been talking about that, or I've been blathering on. The other thing is Low-Z power. What do I mean by that? Z is the technical, symbol for impedance. And impedance is just like resistance, and effectively that's just about power and current transfer. What the hell is Garth talking about again? He's losing this. What does all that mean? Well, what it means is that when you have not so much a preamplifier or a CD player or a turntable or a television, like monitor screen or a projector, but when you've got a power amplifier, these power amplifiers need a lot of current. They need current because their power supplies don't, run off of, like voltage amplifiers with constant current. The current is constantly going up and down on demand depending on the volume that you're playing and how much transient material there is in your audio. So in other words, it's a dynamic flow of current, and we need to make sure that the amplifier gets enough. This is a problem for amplifiers because even though loudspeakers are amazing in terms of what they can do today, the resolution, the emotional impact, the experience, the bandwidth, you know, the imaging, everything about them. But the thing is, in terms of efficiency, they're no more efficient than they were 50 years ago. 90 dB, 1 watt, 1 meter, about true in those days, about true now, sometimes even less. So if that's going to be the case, an amplifier is working full force all the time, not on screaming discotheque levels, not on like some kind of like heavy metal, you know, like playback where you're covering your ears. No, 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 no. You know, like on a grand piano, on an acoustic guitar, those fast transients. Every time somebody does the big plectrum on a lute or a guitar, every time, you know, like the drummer hits a backbeat on the snare, bam! Every time there is a grand piano and they hit the power chord, you know, like in a piano sonata, ching! Every time, you know, like there's a power chord on the guitar, ching! Anything like that that might happen, it's a fast delivery of current. It's essentially kind of like this. There's just in a blink of an eye, you know, like 15, 20 milliseconds or less, just like that fast. You have a situation where there's a peak-to-peak voltage spike or swing from a transient that just happened. Any of those things that I just talked about. Shing! Okay, boom! All of a sudden, in a blink of an eye, here's what's happening, you know, like in slow motion. Well, the power supply in the audio research says, oh my God, there's a huge peak voltage swing. I got to deliver a lot of joules of energy into the circuitry in order to reproduce this. But it's a great power supply and a great circuit, so boy, you better believe it can do this. And it goes out, you know, like back through the outlets into the speaker cables, and you got the big, heavy AudioQuest speaker cables that are very, very large and low resistance and capable of delivering all this current, and it goes through there, and it comes out through here, and it goes into these Vandersteins, and it controls the back EMF of that woofer with a big magnet so it can control that big impact. Boom! And it's got that visceral impact, and it's doing what it needs to do, and you've got all that energy going through. But man, that takes a lot of effort. And if that amplifier could just wipe its brow, if it could just take a little, you know, like rest right now, everything would be fine. But it can't, because audio keeps moving. So as a result of this, after that first transient, it's in trouble. Because the impedance of the power supply went from a fraction ohm down to nearly zero, and now without a buffer, now without some means of recovering, now without the means of getting a lot of current on demand from your wall outlet really quickly, you're going to be in trouble. And one of the reasons that a lot of amplifier manufacturers for years have said, I don't care who designed the power conditioner, regenerator, transformer, whatever, or battery system, whatever you think you've got, I want my amplifier plugged directly into the wall. I don't believe them. Maybe for the source components, that's fine. But for an amplifier, no. And you know what? Even though I'm in the game of power for over 20 years now, I kind of tend to agree with them. Because 90 to 95% at least of the power units out there, even the ones that say they have high current outlets, don't really do a whole lot to fix the problem. They just make sure that they don't go through any circuits that are going to make the problem even worse. But that's not really fixing the problem. I wanted to fix the problem. I started working on this when I was with Furman, but I really perfected it once I got to AudioQuest. We have something called transient power correction. And effectively what I'm doing is lowering the transient impedance below what it would be even with a 20 amp dedicated outlet, which is normally what they ask you to provide if you can. And, although a little consolation if you're in a rented place and you can't rewire it, you know, like an electrical supply or service. And I'm giving the amplifier a current reservoir of over 90 amps peak. To get the equivalent of even part of what I'm doing in the Niagara, you would need to tell your electrician to supply you with not a 20 amp dedicated outlet, but about an 80 amp dedicated outlet. And you would need to ask them to, after that, and they look at you and they try to explain to you that we can't run wire that big through your wall. Then the next thing you need to ask after you get past that hurdle is, could you please take my sound room and move it within about 200 yards of the local substation? A little impractical. I think, you know, like dealing with, you know, the Niagara would be a little bit simpler than that. But again, I could be fibbing. So let's listen to something. I'm going to do a recording of acoustic bass with Aeolian wind chimes. And it is everything is currently plugged into the Niagara system. But what we're going to do is listen to that, and then same volume, same everything. We're going to disconnect, we're going to keep the source components into the Niagara, but we're going to take the 3 amplifiers, which are effectively the 2 subwoofer amplifiers in the Vandersteen 5s, and the large audio research amplifier, and we're going to run them directly into the wall, just like 95% of the power amplifier manufacturers tell you to do, and most of the magazines, common wisdom. Oh yeah, amplifiers, gotta run the source components, yeah, sure, into your power conditioners and so forth, fine, but amplifiers, it'll current compress, it'll make things thin, it'll make things muddy, it'll make things slow, it'll constrict the dynamics. Everything will just sound like you're on your last limbs, just barely making it through. Everything's got that 12 volts, you know, like what's sometimes called like the bad car stereo like effect, where you know it's like you're downtown USA, any place, you know, like Friday or Saturday night, and you're hearing from a quarter mile away. You know, as the quarter panels are like vibrating off the chassis, and bolts are spitting down the road, and you know, basically, I'm a trained musician. Most of my friends are as well. We're the kind of nerds that'll like tell each other, you know, like when a dime drops on the pavement, you know, B flat, you know, like F sharp, but you know, like you know, identify that note. But you know, a car like that comes by, and I'll just say like Matthew, $100, you know, like sing the melody. I'll never lose. It's one note bass because it's the distortion is so high. Because they're trying to reproduce in a cheap car stereo with entirely current, because they've only got 12 volts to work with. It's physically impossible at the kind of sound level that they're trying to do. So we don't want to get anywhere near that, and so that's what we're going to listen to. Listen to the sound stage. Listen to, not just the bass. Listen to the extreme highs. Listen to the presentation, the sharpness, the clarity, as well as the control of the bass. We'll listen through the Niagara the first time, like I said, and then the second time, we'll just take the 3 amplifiers and run them to the wall and see what we hear.